Greetings YouTubers, I'm Rick the Tech Enthusiast here with the next Elegoo lesson number 15, MAX7219 LED.Matrix module. In this lesson, we'll become familiar with the .matrix module that's provided with the Elegoo kit. We'll build and configure a simple circuit that is provided in the tutorial to demonstrate the functionality. So let's start building. The 8x8 MAX7219 LED.Matrix module that is included in the kit has a built-in serial interface that allows us to individually control each of the LEDs with only 3 data lines. Originally, I thought this was similar to an I2C device, but the library author indicates it implements a SPI-compatible slave interface. The data pins are not required to be connected to the Arduino's MOSI or SCK pins. They can be connected to any digital pin available, which does allow for greater flexibility. The 5-volt power requirements range from 320 milliamps to 2 amps, which really depends on how many LEDs your sketch turns on at any one time. The sketch or the library can switch on and off the LEDs in about every 1/10 of a second to trick the human eye that it's constantly on. That is usually set up by the brightness method. Output pins are conveniently included in the module so that you may connect up to 8 devices. However, there isn't any error checking being performed, so jumpers longer than 10 centimeters or 4 inches between each matrix module may run into issues. The datasheet, LEDControl website, and the Arduino website recommend that a dedicated power supply should be connected to the Arduino if you plan to connect more than one LED matrix. And of course, the tutorial, the datasheet, and the websites have additional information on the MAX7219 LED.Matrix module, and I encourage you to check them all out. For this lesson, we'll need the following items from your kit: the Elegoo Arduino UNO R3 board, the MAX7219 LED.Matrix module, 5 female to male jumper wires, and that's it. On page 109, you'll see the following schematic. A jumper will be connected between the DIN pin to pin 12. Pin CS will be connected to pin 11, and the clock pin will be connected to D10. If it was up to me, I'd like to connect the DIN pin to pin 11, the CS to pin 10, and the clock pin to pin 13. But we'll keep things just as they are for the sake of the tutorial. Then there's just the power and ground. Simple. On page 110, you see the wiring diagram with a photo on page 111. Note we're not going to use the breadboard. We're going to directly connect the jumpers between the Arduino and the LED matrix module. Okay, let's jump to the code. As before, we'll load the recommended sketch provided in the tutorial. Go to the File menu item, select Open, and browse to where you saved your Elegoo files. Under your language, Code, under Lesson 15, MAX7219 LED.Matrix module, MAX7219, and open the MAX7219.ino file. Looking at the code, you see that it begins with a new library, LEDControl.h. To verify if you have this library, go to the Sketch menu item. Select Include Library. You should be able to see if you have the LED control already installed. If you need it, you can install a library provided with the Elegoo files. But I'm going to recommend that you use the Manage Libraries to upgrade or install any libraries first. If we select the Sketch menu item and then select Include Library, and now select Manage Libraries, we get the Manage Libraries window. In the upper right-hand corner in this search bar, enter LEDControl and hit Enter. The manager will search a list of available libraries. One of them is the LEDControl by Eberhardt, now I'm going to mispronounce this, Vahal, version 1.0.6. Select it, and an option to install the latest version will appear. Click the Install button. Note that the LEDMatrixDriver library will probably be used later in the tutorial. Now, once you have it installed, you may need to restart your Arduino IDE. Now, I already have it, so I'll just hit Close for now. The next line instantiates the LC object as an LEDControl with the passed values as pins used for this object. 12, the data in pin, 11, the CS pin, 10 as the clock pin. The value 1 indicates the number of MAX7219 modules connected. In our case, it's just the one. Then we have two unsigned long values, delay time and delay time 2. Now these will be used later in the sketch. The void setup starts the LED matrix by waking it up, setting up the brightness, and then clearing the display. The void write Arduino on matrix is a function or subroutine that displays the letters for the Arduino one at a time with a small delay of delay time 1. It begins with defining each letter as a byte array. Each binary value contains the LED on or off values for each row. The function then uses setRow method to light up each row according to the binary value stored in that array index. The initial 0 in the method is used to indicate the first LED matrix that is connected to the LS object. Also note the library will handle the LED switching. The void rows will loop through each row and flash two LEDs defined by the binary value 101000000. It uses the method setRow. The void columns will loop through each column and flash two LEDs defined by the binary value 101000000. It uses the method setColumn, which is similar to setRow method. The void single will light up through each row and column and light up every LED in the matrix, blinking them 4 times as it goes along using the setLED method. The setLED method requires both a row and column indexes. The last parameter is a Boolean value. A value of true turns on the LED, a value of false turns it off. It begins with row 0 and then loops through all the column LEDs, working its way from left to right, top to bottom. Finally, the void loop calls each function one at a time and then loops. Let's upload the code and try it out. All right, so the first thing it does is it runs through the write Arduino on the matrix, which is basically spelling out Arduino. And then it goes through the rows first, and then the columns, blinking 2 lights, 2 LEDs. Then it goes through the turning on the single LED routine. As it goes across, it blinks the light 4 times, and then it continues. And then it repeats. I see they didn't clear out those columns before the Arduino on matrix. But then it goes through the rows and columns and that clears it out again. Interesting note is the letters were on the side. I'll have to look into that. Excellent. Did you notice that the letters were sideways? Why did that happen? Well, do you remember the code for the byte arrays, which consist of binary numbers? Each binary 1 or 0 turns on or off a particular LED. And in this case, the binary values were arranged like this. Here's a little chart. For row 0, which is the first row, the binary number was 01111110. These values look like this when plotted on the LED matrix. As you can see, each subsequent row develops the letter, but it's arranged sideways. The last 3 rows are not defined, and that's why we see LEDs on when perhaps they should have been turned off. Or we could have used the LED clear function. Okay, for grins, let's try this marquee text example from the LEDMatrixDriver library. So let's install the new library. Select Sketch menu item, then select Include Library, and now select Manage Libraries. This opens the Manage Libraries window. In the upper right-hand corner is a search bar. Enter LEDControl like we did before and hit Enter. The manager will search through a list of available libraries, and one of them is the LEDControl. The other is LEDMatrixDriver. Select it, and an option to install the latest version will appear. Click the Install button. Let's open up the marquee example. Select the File menu item, then select Examples. Scroll down until you see the LEDMatrixDriver. Select it, and then select Marquee Text. The IDE will open up the example. Now let's save the example as My Marquee Text so we can make changes to the sketch. Okay, the first line is, well, of course, the LEDMatrixDriver library. Now this library is hardwired for the DIN pin to pin 11 and the CLK pin to pin 13. So remember to change the jumpers accordingly. The constant unsigned integer LED matrix underscore CS underscore pin is used to set the CS pin, and in this case we'll use the pin number 9. The next constant values define the matrix width, height, and the number of units. We'll have to change the LED matrix underscore width to 7. The next line instantiates the LMD object. The void setup enables the LMD object and sets its brightness. This is followed by some global variables X and Y and a large byte font array defining all the various letters and all the other characters that can be displayed. The values provided are all hexadecimal. The constant ANIM, which I think is from animation underscore delay, will set the speed of the marquee. The char array text will have the message, and the integer len will get the string length of the array text. The void loop starts with a call to the drawString function. The drawString function loops through each character in the text array, which passes an Arduino ASCII value and then subtracts 32 from it. This automatically provides the appropriate font index value. Pretty cool. Then it checks if the character is outside the visible matrix area. If it is, it returns, or goes on to the next character. Then it checks if the character is visible and calls drawSprite. Void drawSprite does all the hard work. This draws the sprite, or in this case, the character, to a given position using the width and height supplied. It loops through using a mask technique to only show the appropriate character bits that should be shown given a specific position. And then it loops through all those positions or rows to that appropriate portion of the character is drawn. Back at the void loop, it displays the new buffer frame. It then has a small delay and then increments the X coordinate. And that's it, and then loops through. Let's upload the code and check it out. All right, we're going to go ahead and run the marquee text sketch. Everything is running so quickly, it's like a blur. I can't make out heads or tails on any of this. It does go through the LED matrix demo is what it says, then the numbers, the letters, and then the symbols. But it's so quick, I can't see it. So I'll make a small edit to the code. We're going to change the animation delay to 100 and then upload it. That's much better. You can actually now read the text. LED matrix demo. And then the little 2 asterisks as it goes through all the numbers. And then a couple plus signs, but then they'll go through all the letters. A couple more plus signs, and then I'll go through all the symbols, at least the ones that are defined. That looks excellent. Very impressed. And just for grins and giggles, I created this little spreadsheet to kind of create your own LED fonts. Here we have 2 boxes of rows and columns. The one on the left is where you would build the font. The one on the right is where you would see the font again. And down below, I just have it where you can copy the hex string that it creates and copy it below, so that way you can have a list of hex values for whatever various fonts you've created. It also has a binary string in case you wanted that instead. I didn't create the right box to automatically build from the binary. It's only set up to run from the hex, but it's still a pretty valuable tool. And it's simple by going into the left box and just clicking on X on whatever box, row, and column you want to highlight. It'll automatically darken. If you want to get rid of that box, you just hit delete and it automatically goes away. And then the binary and the hex values are auto-generated. Very, very cool. I hope this could be a valuable tool for anybody who is looking to design or build their own LED fonts. Well, that's it for this lesson. I hope you've enjoyed learning a little about the MAX7219 LED.Matrix module using both the LEDControl and the LEDMatrixDriver libraries. If you like this sketch, be sure to let me know in the comments section below. I'll have additional links for other interesting videos and code for this project in the show notes below. Join me next time for Lesson 16, GY521 module. If you like this video, don't forget to rate and subscribe. I'll try to put out a new video each week. Thanks, and see you next time.